So let's say the child faces some form of neglect or early life stress. How does that actually affect the brain? So let's zoom inside the brain again.
Yeah. So there's a window of time in the first I can tell you for rodents very clearly because we understand it beautifully. But for humans, we don't know the exact window of time in which this is. I cannot give you literally this is the window. But rats and mice, it's the first 2 weeks of life. So by the time they're 1 month old, they're fairly independent. They can forage for food by themselves. They're adolescents by the time they're 1 month old. So for that species, it's the first 2 weeks in which they are highly dependent on parental nurture. Depending on the species, it could be either both mother and father, or depending on the species, sometimes it's just the mother, the dam, which is what they're called. So whoever the caregiver is has to provide all access to nutrition, first and foremost, but warmth, touch, stroking, nurture, staying in the nest, etc. are all critical components, right? And if you don't provide that, the brain starts sensing that there's something not quite right in terms of course, nutritional deprivation is a serious problem. But let's say even if nutrition is provided, but nurture and touch and care is not provided, the brain detects the absence of that, likely through a small peaking of stress hormones in the body. And then you use that to determine, in a sense, you're making a prediction of what's going to happen when I'm an adult. Is it likely that I need to be prepared to be in adverse environments? If I need to be prepared to be in adverse environments, I need my stress response axis to be super sensitive and super able to help me handle stress. So you end up programming a hyper-vigilant, super active stress pathway that now is overreactive.
Easily get stressed.
Easily get stressed does not come back to baseline fast. Okay, so for example, let me give you a concrete example. So for rodents, it's cortisone. For us, it's cortisol. Okay, this is our stress hormone. This stress hormone is sort of vital for you to do anything you need to do under a condition of stress. And because it's evolutionarily old, it was designed not for, being stressed out during a podcast, but it was designed for being stressed out when you're out in the savannah or you're a hunter.
Survival instincts, yeah.
Exactly, right?
Tigers behind,
exactly.
Yeah.
So you were either prey or you were predator. So if you were prey, you had to run away. So if you have to run away at that moment in time, your hormones have to help you shut down digestion, shut down reproduction, increase glucose supply to your muscles so your muscles are optimally ready to allow you to run, etc. So you're redistributing your resources in your body to allow you a chance of escape, right? You're also preparing your immune system to say, get significantly more active because I might get attacked and then I need to have all my circulating natural killer cells, etc., all prepared to anticipate trauma to my body. So that's what these hormones are doing. They are redistributing resources in your body to allow you to fight or flight, right? So that's what they are optimally designed for. Now, also the view is this is going to be short-lived. It's going to go and go away. Either you're going to be eaten or you have run away. One of the two is going to happen. So you're not expecting to do this for hours and hours at an end. You're expecting to have a quick spike and then this matter gets resolved. So cortisol has this tendency to spike to about its peak level within 20 minutes of onset of a stress. And by a couple of hours, usually it's coming back to normal, right?
On its own.
On its own. Because there is a very nice feedback regulation pathway for this axis. It's actually controlled by the brain, which then tells the hypothalamus and the pituitary to say, okay, enough. Shut down secretion of cortisol, which is made by your adrenal glands. Stop the pathway. Now enough. Okay.
But you can do things to bring it down faster?
It depends on how optimal your feedback response is. Now that feedback response gets set in the early window. So that's your tuning. That's what that early life is helping you do. You're deciding how hypersensitive or how do you want to tune this stress response pathway. So if you tune it to be super responsive, it's not going to jump out of its skin for everything. And it may also not come back to baseline fast enough. So it's just that, and this is one of the most common side effects of stress, which is that you're hyper vigilant. You're imagining things jumping out of things at you where sometimes there is no obvious stress. You're still continuously anticipating that possibility, right?
On the edge.
Exactly. Now, that could be a great advantage in certain environmental contexts because it will give you a survival advantage. And in some contexts, it could be terrible because you're continuously bathing your body and brain with cortisol, which you don't want to do. So think about it as an evolutionary design to help you predict your future. So your first few years for a human, let's say first 5 to 7 years, is also that similar window. You're using this to determine, what do I want to do with my stress response pathway and my emotional neurocircuitry? The same way you were doing it with your visual nervous system, there are circuits in the brain that are dedicated to processing fear, awareness, attention, etc. You're using this time window to kind of figure out for yourself, how do I want to prime and optimize and fine-tune these circuits? So high degree of stress in those early windows trains that circuit to be hypervigilant, overly responsive, overly activated, less likely, also more likely to generalize, which is to say that something is stressful but something isn't. You tend to spread the stress to situations that are non-stressful. This tendency to generalize stress to events that might be non-stressful is also a component of having a hypervigilant stress response pathway.
And this can be rewired as an adult? Is it reversible, or you're in a deterministic path in life?
It's not deterministic. That's the greatest thing about the brain. The beauty about the brain is that it is open to continuously taking feedback and readjusting itself based on the feedback that it gets from its environment. But like I said, the early window is sort of monumental because that window tends to fix things harder than any other window later in life. So if you try to override what happens in that first decade, it's much harder to override stressful events that have been early than it is to override stressful events that happened in adulthood. Okay? I don't want to leave you with any sense that it is deterministic because there are enough examples in humanity for us to see people who have surmounted surreal stress, right? So that itself is a fascinating question as to what promotes resilience. What makes some individuals so resilient that despite severe stress, they surmount it, right? So there are resilience pathways, and there are ways to train resilience pathways and get them to help you to surmount a stress. But early stress is particularly bad because it has this tendency to have long-lasting impacts long after the stress is gone. Because it happens in the window in which your brain is using the environment to predict future environments, it is also using that information to readjust its sort of circuitry and function to prepare for the future. So in a sense, if you think about kids before the age of 10, that window they're using as a sort of an optimal sensing device of their environment to decide what the future environments are going to be like and how do they get their circuits to kind of function most optimally for that.